Welcome to Edisoft Virtual Labs. The aim of the experiment is to determine the dead time of a Geiger detector by the variable area method. The apparatus used will be a digital counter. A source holder, a Geiger Muller tube, a source cabinet made of thick lead, radioactive sources, and sheets with different opening areas. If an ionizing particle, such as alpha particle, enters the Geiger Muller tube through the window, it loses its energy by creating electron-ion pairs. The electrons that are produced in the resulting avalanche are accelerated to the anode, and collected in a short period of time. The positive ions, however, are more massive and make their way slowly to the cylindrical cathode. If electron-ion pair average transient time is called delta T1, the GM tube is busy during delta T1. If another ionizing particle enters the GM tube during delta T1, it will not be counted. This time is called the dead time of the tube. Then the dead time is defined as the time following the counting of ionizing radiation, at which the counter is not detecting. Also, the recovery time is that time elapsed for the detector to be ready to count. If the dead time of the GM tube and the correction factor, which can account for these lost events, is determined, the number of actual incident detected radiation is obtained. If the counting rate for incident ionizing particles or radiation is Ri, and that detected by the counter is Rd, then the number of undetected radiation in time is given by the following equation. If we rearrange this equation, then we get the following form. Since Ri is proportional to the area of the detector, then Ri equals Ka, where K is constant and I is the area of the detector. Then the equation will be in the following form. The relation between 1 by Rd and 1 by A is a straight line intersecting the y-axis at tau. Now let's start the experiment. Set up the electronics as shown. Before you start, make sure the mode is set to operating voltage, and there are no sources outside the lead shield. Switch on the Geiger counter. Set the timer to a specified time. Set the voltage at a specified value. Press count to start counting the background activity. The counter will automatically stop. Place a radioactive source on a shelf of the GM stand at a suitable distance. Press a raise to zero the counter. Press count to start counting the source activity. The counter will automatically stop. Put a sheet of an opening area A in front of the GM tube window. Be sure that the sheet thickness is enough to absorb the incident particles, and only those passing through the opening are detected. Press a raise to zero the counter. Record the counts N, and then calculate the rate R. Repeat with sheets of different opening area. Make sure that the source is always placed in the same position. Record your data in a table. Draw the relation between 1 by RD and 1 by A, and from which you can determine tau.